Okay, I'm back. So I showed you this schematic, which is what I'm going to use to explain initially that orbital structures, constructing structures, and then we can go to the remaining two methods, and I'll come back and touch on those as well. Okay, so I want you to have that schematic from the PowerPoint while you watch this video so you understand it better. Okay, so I am going to pick a random element, say sodium. Okay, sodium. Okay, so Na. Okay, I want to first write down the sequence before I start constructing my shells. Like I said, this will start to get a little bit more confusing if you're trying to do it for some of the lower group elements. It's just very difficult, but it's doable. Okay, so sodium. So let's go back, and you see sodium is in the third row right here. Okay, right here. Okay, but we got to get through all these guys before we can get to sodium. So we have a 1s first, and then there's a 2s, and there's a 2p, and then if you see, we're already in the third row now, and sodium is right up there in the 3s bracket, right? So you just say 3s and you stop there. Okay, now we use our, I'm going to change this color to a blue just to put my bracket here and then the numbers that I'm going to fill. So if you see, I said that this is the maximum number of electrons each orbital can hold. Okay, right now we're not in D or F, so we don't need to focus on those, but all we have is S's and P's. Okay, so an S orbital can hold 2 electrons. So now you've got to start from the left, you go to the right. You don't go from the right to the left and fill as many as you want. Now if you go back to the periodic table, now let's refresh our memory. Sodium has an atomic number of 11. What does that mean from our practice exercise? It's got 11 protons and 11 electrons. We'll come back for neutrons when we're ready to construct our structure. We'll do this one more time. Okay, so let me change to a different color this time. Maybe go to a black. Okay, because black's very obvious to see. Now we have 11 electrons. Let's not focus on the proton because this is only for the electrons. This is not for the protons or the neutrons. The shell structure that surrounds the nucleus is what the complicated part. So whatever we're trying to do is purely for the electrons. So we have 11. So we know that, and I said you go from left to right once you have written the sequence is, well, S can only hold 2. So I'm going to give the full 2 for it. Okay, 2s, don't worry about the 2 or 1, just focus on the s. S again can hold a maximum of 2. Okay, p can hold a maximum of 6. Okay, well, if you count, 2 plus 2 plus 6 is 10, but we want 11 electrons. And S can hold a maximum of 2, yes, so we can accommodate one more here. Now if you add it, it becomes 11. Now the magic and the beauty of chemistry is something I will probably talk about at the end of this when I'm finishing reviewing this material is chemistry is science, so things should add up. Okay, so in life when we say things don't add up, when people say us things like my grandma died the 10th time because she couldn't do the homework, well, things don't add up. Your grandma can die 10 times. Okay, that is scientific. You can only die once, right? So something like that, that one that we added will make sense, and I'll come back and tie it to the periodic table, I promise. Okay, but let's do one more practice or a couple more practice just to get this sequence done. Okay.